channel. In this video, I'm going to try to solve this problem, do some live coding work. At the same time, I'm going to follow the general steps you should follow in a coding interview. So first of all, let's read through this problem. There are n gas stations along a circular route where the amount of gas at the I station is gas I. So we have a 1D array gas which contains so each net number within the array is the total amount of gas at the gas station I. So you have a car with unlimited gas tank and it cost I of the gas to travel from I station to its next I plus 1 station. So you begin the journey with an empty tank at one of the gas station, and given two integer arrays gas and cost, return the starting gas station's index if you can travel around the circular once in the clockwise direction. Otherwise, just return -1. So if there exists one solution, it is guaranteed to be unique. So it's like we either have a solution or we don't have a solution. But when we have a solution, it's guaranteed to be unique. So let's see the first example. We have gas station having the gas as 1, 2, 3, 4, 5 at the corresponding index, and the cost to travel from 0 to 1 is 3, so on and so forth. And the output is 3, which means we can start from 3. So we are just going to save the time for the explanation part. Let's see the constraints. So the constraint says the gas length is equal to n, cost length is equal to n, which means the length of gas array and cost array is going to be the same. And n is anywhere between 1 to 10k. So there won't be any empty stuff, and also each of the number within gas and the cost array is going to be anywhere between 0 to 10k, so it's going to be non-active integer. So currently there isn't too much of the room to think about edge case, because based on the constraints, everything is legal input. So let's think about how to solve this problem. So how to solve this problem? So what we could do, of course, the first one that comes to my mind is to do a brute force solution, which means we can try every start point to see if we can successfully travel in a circular once in the clockwise direction. But that is not going to be efficient because the runtime is going to be n squared. So another way I can think of when trying to solve this problem is to include some intuitive idea when we try to solve this one. So let's say we have 8 gas stations. Let's say we have 8 gas stations: 1, 0, 1, 2, 3, 4, 5, 6, and 7. So we have all of the gas stations. Let's say we can successfully travel from 0 to 3. But when it comes to from 3 to 4, we cannot really successfully travel from 3 to 4. So it's something like we can travel all the way from 0 to 3, but when it comes to 4, we cannot really get there. So do we actually need to restart from 1? So the answer is no. That is because from 0 to 1 we are successful. Then it means the gas minus cost is for sure going to be larger or equal to 0, which means at gas station 1 we are for sure, for the current tank, for sure it is either empty or we have more gas to travel along the distance. So we actually don't need to restart from 1, but instead what we could do is we could just start where we fail, which means we just start from 4 and then continue to do the rest of the work. So if at the end the total gas minus the total cost is larger than 0, then we actually find a start point we could manage this travel. So that's the thinking. That's my thinking about the solution. So in this way, we are just going to do a linear scan, which means it is going to be a O1 solution. So having said that, let's do some coding work on top of this solution. So first of all, we are going to have a variable which is the current gas. So we initialize it as 0, and we have another one which is total gas as 0. And then we are going to go over each of the index anywhere from 0 to gas dot length plus I. So we are going to have the current gas as equal to plus equal to gas I minus cost I. So if the current gas is smaller than 0, what we are going to do is we are just going to start from the next position. So actually we need another one, which is so let's say it is called successful start as equal to 0 at the very beginning. So if the current gas is smaller than 0, as we said, we are just going to start from the next position instead of looping from. We are just going to start from the next position. So we are going to set successful start as equal to I plus 1. Since we try a new start point, we are going to set our current gas as equal to 0. And for the next one, and also at the same time, we need to we need to update our total gas, the same as gas I minus cost I. So if at the end the total gas is larger or equal to 0, then we are just going to return successful start. Otherwise, we are just going to return -1. So we could just say, okay, return is the total gas larger or equal to 0. If yes, then we are going to return successful start. Otherwise, we are just going to return -1. So I'm just going to rely on this platform to help me to debug. Okay, so it seems to be good. Let's do some. Okay, so additional test case passed. Let's do a submission on top of it. Okay, so that's pretty much it for this solution and this piece of code. If you have any question about the solution or the piece of code, feel free to leave some comments below. If you like this video, please help subscribe to the channel. I'll see you next time. Thanks for watching.